Okay, guys, let's finish up this lesson on logarithmic rules here. So last two examples that were very similar to the last ones I covered in that part 2 video. This one is asking me to solve for x again. So that means I have an exponent, a base of 4 with an exponent of -3/2, and that equals x. Well, that means I really have 1/4 equals x. Well, really what that means is I have the square root of 4 cubed. And you could, really I could do that in either order. I could cube it first and then square root it, or I could square root it and then cube it. Either way, I should end up with 1/8. So let's say I cubed it first. That would be 4 to the third power is 64. The square root of 64 is 8. If I square root it first, that's going to be 2, and 2 to the third power is also 8. So either way, it doesn't matter. So I end up with 1/8. Let's check just to make sure. If I plug it back in up here, I get the log base 4 of 1/8, which is a positive value. So this is okay. Okay, this one, same situation. I've got, this is really a base 10, right? So that means I have a base of 10 with an exponent of a -4, and that equals x squared. Okay, so really what that means is I have 1/10 to the 4th equals x squared. Let me write that a little bit bigger on this next one. So 10 to the 4th power, that's really 10,000 equals x squared. All right, so if I square root both sides, so this is where a lot of people are like, what? How do I do that? Okay, so first of all, don't forget you would get the, your answer would be plus or minus because we're square rooting. The square root of the top is 1, and then the square root of 10,000 is 100. Okay, so I get a positive or a negative. So the question is, when I plug this back in, if I get plus or minus, I need to check in on 1/100, and I need to check -1/100. So if I put 1/100 in here, I'm going to square it. So yep, that's positive. If I put in a -1/100, I'm going to square it. So yep, that's positive. So both of these work. Okay, this last situation here, they use some terminology that I'm not sure if you know. I'm not sure if you covered this in Algebra 2. So I'm just gonna go through it real quick so that you know. So they want me to approximate these answers to 3 significant figures. So let me explain what that means. First, let's talk about this problem. So this is a base 10. So this is telling me that 10 to the 1.8965 equals x. Well, that means I need to take 10 to that exponent, right? So I'm going to do that on my calculator real quick. So I've got 10. I actually had just done it. I should have just left that there. 10 to the 1.8965. And I get an answer. Well, they want me to give my answer to 3 significant figures. So I'm approximating this, but only to 3 significant figures. That means figures that aren't 0, in other words. So in this case, I'm just going to take those first 3. So 78 point, and then I'm going to round that to 8. So it's about 78.8. So x is approximately 78.8. Okay, so this one, same thing is going to happen, right? I'm just going to have 10 to the 4.9680 equals x. So x is going to be approximated to some value. So I'm going to do 10 to the 4.9680, which you don't have to put the 0 in there. And I get about this. Now, this is where the significant figures come in. So this gives me 92,896, but I only need 3 figures. So 9, 2, and then that would round up to a 9. So I'm just going to round this to 92,900, and I'm going to stop there. So 3 significant figures are right there, 929. Okay, this one, same thing. I've got a base of 10, an exponent of negative 2.2. That's going to equal x, which means x is going to be approximately something. You're definitely going to get a decimal here because this is the same thing as 1 over 10 to the 2.2, but I can just type it into the calculator as is. So 10 to the negative 2.2. And then I have to have 3 significant figures. So no matter how far back I have to go to get those, I have to have 3 numbers, right? So I've got 0.00 and then 6, 3. This will round up to a 1. So I'm going to round this one to 0.00631. Okay. All right, then we move into some natural logs. So let's go back to our rules here. A natural log is the same thing as log base e. So I'm going to rewrite this as log base e of x equals 3.7. So really I could write this as e to the 3.7 equals x. And remember, e is just a number, so I can figure out what that is. So I'm just going to write it over here. X is going to be approximately, and again, I'm going to use my calculator. This time I'm going to do e to some exponent. So I have to do second natural log, so that's e to the, and then this one is 3.7. That gives me about 40.4473, blah, blah, blah. So I just need 3 digits. So this 0 right here, that can still be a 0. That still counts as one of my significant values as long as it's not zeros on the end or zeros at the beginning, right? So I'm going to count this as 1, 2, and then my third one right there. So about 40.4. So 40.4. All right, so this one, I'm just going to take a shortcut and say if it's a natural log of x, I can just solve it by saying this is e to this exponent, 0.95. All right, so I'm going to do again e to the 0.95. That one gives me about 2.59. Okay, and then my last one, I have e to the negative 5th. So e to the negative 5th gives me, I'm going to have to move my numbers here. So I've got 0, 0, 6, 7. I'm going to round that one up to 4. So the 6, 7, 4 are my 3 significant figures. These zeros up at the beginning don't really count. So x is about 0.00674 in that case.